Hi! In this episode, I'll show you how to quickly program histogram analysis of images in Python using just a NumPy library. Histogram analysis is a straightforward, convenient tool for encoding images into vectors compatible with machine learning models' input. You can use this step in your exploratory data analysis to determine if your classification task relies on the image's color and start estimating your dataset's quality. You may think it's trivial, but I recently used it to make a medical discovery. It's more valuable than it seems. So, lecimy z tematem. In this tutorial, I used 4 libraries: NumPy for mathematical computations, XGBoost for classifier model, sklearn for utilities, and matplotlib for presenting data. In the first step, I created a dataset of images used for binary classification. Each of them has size of 32 by 32 by 3. The rules of their creation goes as follows. The red channel is random, the blue channel is random, but the green channel depends on the image class. If the image class 0, then green values are sampled from the univariate distribution from 0 to 150. If the image is in class 1, the distribution ranges from 105 to 255. The distributions have a bit of an overlap, but they also have very significant differences. Here you can see the image of class 0. Its green channel averages around 75, while channels red and blue average around 127, so the image seems slightly purpled. Now, the image of class 1 is presented. The averages of red and blue channels stay the same, but the green channel's mean jumped to 180, so the image is greenish. Despite their inherent randomness, the pattern is obvious to extract. Now, it is time to convert the image into a histogram. By histogram, I mean its vectorized version. There's no point in interpreting the histogram's chart when we can represent it as a vector. To do so, we take the image and select the channel we want to encode. For example, the histogram of green channel values requires the selection of green channel and disregarding channels blue and red. As a result, we obtain a matrix of 32 by 32. A bit closer. Now, we reshape it into a one-dimensional vector of size 32 multiplied by 32. To do so, we use the NumPy function reshape with argument -1. -1 in this example means just put everything you can into this dimension. Really. Afterwards, the NumPy histogram function will do the trick. Warning! Here's a common trap that even I got hooked up on while making the tutorial. You have to specify a range of the histogram. Why? Histogram analysis allows machine learning models to interpret the image only because each vector has the same structure. For example, the first cell in vector represents the number of values from the range of 0 to 20, and the next one from 20 to 40. It is important. If you do not specify the ranges, NumPy assumes that the ranges are from minimum to maximum. It means that cells can mean different things among different vectors, and that is simply wrong. In other words, just always put ranges into the histogram function. So, we made a histogram out of an image. We can quickly present it using the stairs plot. Let's use that function and dataset generation function to create one function that will randomize images, take histograms out of the selected channel, and split it into train and test datasets. Then we will take these sets to train XGBoost classifier. As you can see, with the channel variable equal to 1, representing the green channel, the resulting accuracy is 100%. Nothing out of the ordinary, since we generated the images in a way to be distinctively more or less greenish depending on the class. For channel red, we got an accuracy of 52%. Understandable. In the red channel, there is no information regarding classification as the images were sampled from identical distributions. Blue channel got somehow lucky and scored an accuracy of 56%. It is quite a stroke of luck for a purely random image generation, but for any usable model, it is not. Quick automated analysis of histograms prove that green color contains valuable information for image classification, and blue and red channels don't. In the last step, The visualization of histograms is performed. We split the training dataset into vectors representing classes 0 and 1 separately. Then we make an average vector representing each class in each channel. The result, the histograms of green channel, shows what the XGBoost algorithm saw: clean separation. On the other hand, the histograms of red and blue channels are almost indistinguishable. The visualizations show that the XGBoost algorithm presented to us. The green channel is color-wise important, but the red and blue channels does not. Of course, histogram analysis is merely one of many data scientist tools. It can only determine the usefulness of global color distributions. It doesn't mean that the red and blue channels are downright useless. For example, class 0 could have had red circles and class 1 red squares, and the global distribution of red color could have been the same. Still, temporal patterns would allow for obvious classification in such example. But this tool is easily implementable and interpretable, so it is good to have it in your toolbox. I recently published an article in which I used histogram analysis to make a medical discovery. The link to the article is in the description. The Jupyter notebook with code is also accessible under the link in the description. I also made a video of the application of this method and it should be on the YouTube card somewhere around the corner, I guess. My next video will show the medical discovery I made with this method. Thanks for watching. Consider leaving a like and subscribe, and we'll see each other in the next episode.